Hello everyone. Welcome to another session on AI/ML for product leaders. In today's session, we are going to explore how we can enhance the fraud detection pipeline using XGBoost, one of the offering from AI/ML, and what are the benefits we can expect out of the implementation of the AI for the fraud detection in the banking system. Before getting into details, we need to set our background. So let's hop on to that. So the agenda is primarily to understand how we can accelerate the fraud detection pipeline using VLLM, that's an inference engine, optimized with XGBoost models. It's primarily we need to understand how we can get a superior accuracy, low false positive, and we can detect the fraud within the span of millisecond and mitigate the risk of fraud being happen before it actually happens. So it's basically we are trying to do the proactive determination of the fraud. Before we deep dive into detail, we need to have a look at what exactly we have seen in the past due to lack of proactive AI implementation in the fraud detection vertical. So lately we had a PNB related fraud being seen in the market where we had a loss of 2.1 billion. It eventually caused a loss in public confidence for the bank and RBI. Moving to an international scale, it's with Society Journal. We had an issue where we have seen the fraud that caused massive loss and cost around 7.2 billion of loss because there was no behavioral monitoring for the traders. Basically, no proactively it was able to predict a model or or a behavior that could have anticipated a potential fraud in coming in the system. Similarly, we have seen a Bangladesh bank heist trust issue. They had a partial recovery, but still they made a loss of in total 81 million. So on a whole, the key pattern we have seen there was a lack of cross-channel fraud intelligence, and we are not able to identify the anomalies, and that too we had to figure the same on the large scale to mitigate the financial damage. So for rescue comes the AI use case. So we are trying to leverage the XGBoost model here. So before we get into the technical understanding, we need to understand the business benefits we get by using the advanced fraud detection platform. In the business term, we can get the superior detection accuracy because we can catch most of around 30 to 50% of more fraud cases when compared with the existing traditional rule-based system. Also, this will lower the false positive. Thus, it helps us to improve the customer experience and retention also increases. Since time plays a very vital role here, we can anticipate and we can figure out the fraud within a span of millisecond as compared to the current system we have based on rule engine that covers the same in span of an hours or even days. And also there is a scope of the model to AI model to keep on evolving with the time and to capture the new forthcoming fraud patterns. So if we talk about the pipeline has multiple 8 stages. It starts with ingestion of the data. Then we'll do the data cleansing and validation, which involve the data quality checks and imputation of the missing values based on the logical understanding and the default values in the numerical representation. Then it will be followed by the feature engineering, wherein we'll be iterating through the different attributes that are given for a particular transaction in terms of time, merchant risk velocity, geographical location, and the other relevant categorical attributes. Basically, these are the constants of the transaction given given to us that we need to train our data model AI model against. We'll be doing the test training data split in a ratio of 80/20. Then we are using the advanced feature of smooth resampling. Basically, this is one of the provision that we can provision is given by XGBoost, wherein we can specify a smart valuation. How that helps? Basically, that helps with determining the imbalance data set, so that model gets trained to generalization and doesn't miss out the actual fraud scenarios. Then we'll talk about the classifier, XGBoost classifier, the basic model, followed by the evaluation of the same. We'll evaluate based on the precision, recall, and the ROC curve, and eventually we'll be able to understand and figure out the fraud probability for a particular transaction, that too in a real time. So in this particular data pipeline, the stage one would be, as we discussed at the fine grain level, once we ingest the data, if you see here the test step one, shows that we'll be ingesting the data called train.csv, then we'll normalize the column headers, and we'll do the basic sanity cleansing of data, which involve dropping the empty columns, and we'll be skipping the blocks that are missing for robustness, and such basic data cleansing would be done, followed by time-based features. Then we look into the behavioral and velocity metrics that determines what behavioral of a user can be a potential suspect to be a fraud transaction. We'll look for the same from the feature perspective of merchant location and geographic features, followed by amount transformation and the outliers as well. And eventually we'll be summing the whole pipeline feature engineering part with a categorical encoding, so that wherein we'll be representing all the features and in a numerical valuation that a model would understand and will drive the prediction based on. So before getting into that code, we'll see the new feature that we tried to brought in. We'll be using a combination of date and time features, or we'll be using the term features or attributes interchangeably. They are nothing but just a part of a transaction, because whenever bank transaction is given, it's given with the time, date, when the transaction happened, and who was a merchant, and at what time it happened. All this comes as a feature. Then we'll be doing the cyclic, we'll capture cycles with the transformation that will transform using the sine and cosine methodology. Then we'll look into the how the proximity of a user from the bank can also be one of the suspicion to one of the aspect that we can be skeptical and consider as a potential for a transaction. And the context flag would also be there. Logically, if you see, it will include more transaction happening on weekend and weekdays, or weekend and that too at night, can also help us to determine a pattern of fraud. So if you see here, we have shown up how the merchant customer risk feature can help us to fraud detection, because merchant risk is basically we use the historical data if we have it's available with respect to the merchant, that will help to predict what could be the possibility of a transaction to be a fraud from the merchant end. Then we look for the customer behavior. We'll compute the Z scores. Then we'll do the feature toggle, and then we'll do the valuation based on the the logical valuation, combining the customer and merchant profile to improve the detection. So considering even the transaction looks out to be normal, we need to understand how the merchant and customer are related here. In other words, we can say, despite transaction being correct, looking no suspicion in the data, still we need to see if we see any outliers or any unprecedented relation across between the merchant and the customer based on their location. Here is the use case. If we see distance between customer and merchant, so here we have reduced it to noise of 200, means we have classified it to within up to 200 units as something that's far. Then we have done the categorization for distance and local, and similarly we do other cleansing of data based on the roundness, where we detect suspicion pattern because we have rounded requests. like high number value with multiple zeros. And then we'll be combining the different features to improve our fraud signals. Basically, we are trying to identify the signal based on the user behavior, not only on the based on the number of or the value in the transaction amount. So if you see one of the use case we just talked about, how we can be how we are going to prepare the categorical features. We'll be computing based on, we'll be creating different buckets based on date of birth, and then we'll be see whether date of birth for the consumer, for the end user, and his payment method make a logical relation. So we'll do the label encoding based on gender, category, state, payment method, and device. Then we'll do pipeline will silently will do the encoding for rest of the missing values based on the imputation using the KNN algorithm, wherein we'll be taking the for the same similar set of transaction, we'll be taking the rest value from the rest of the transaction, and we'll take the mean or the nearby k values, and we'll take the average of that to put it as a value for the particular transaction as the input value. Then we have polynomial feature for better fraud detection, because if we see amount and hour, it means high amount transaction done but late at hours, in late hours. Amount into flag, it again when a flag is true means it's done at night time. Okay, then we'll further categorize if it's a distance and the amount. Joint effect means high value transaction but for a long distance between the merchant and the bank. Then we see card age and the amount. Though card is going to expire or it's very old, and suddenly there is a surge in the amount. Similar combination will help us to combine the interaction and polynomial terms to detect complexity basically. So we are using the multiplication of the different scenarios or different features to handle the imbalance for better fraud detection. For example, if we see there must be some data that are minority and model might not get it trained well for those leftover minority transaction, and but that might turn out to be fraud. So we need to generate the synthetic data. So using XGBoost scale pass weight feature, that is something confining to Smart, it will be able to generate the synthetic data, and it help us to tune via Optuna. It's one of the way to maximize the PR AOC value that used to determine the efficiency of a model to do the prediction for the given transaction. Now followed by that, if you see, we do the cross validation, and coming back to detail onto SMOT that we just talked about, it's basically a synthetic minority oversampling technique. It do nearest k neighbor search. So as we just said, it find the k nearest minority class fraud samples to predict for each minority seed. To select the neighbor, and it will interpret it against the vector basically. So we are generally creating the synthetic data, in other words. So if you see, here is an architecture diagram of how study initialization and then trial suggestion. Trial suggestion basically it's more like we are doing multiple trials for a model. XGBoost setting a parameter that the more is the number of trial, more refined it would be trained against different combination of data sets. And we'll compute the PR AUC on the validation data set to determine the fraud detection. And another aspect would be to use the early stop pruning. It means whenever we are seeing a trial and it's showing us the poor intermediate result, in that case we can prune the tree and we can go to another trial. Probably we are intending to figure out wherein our terminal trial shows a good result, and we'll take up only those trials in consideration to set the model understanding for the transaction data. And while this trial, whatever the best found parameter was determined would be used to retrain and deploy the final XGBoost model to train eventually. So if we see, there is still a scope. If we want to deploy the same application on a large scale, we need to use VLLM here. That's one of the very promising inference engine, because we see most of the AI ML products are having a lot of operational cost because of the inference engine. This would be our forthcoming topic to discuss, where we'll see in a use case how VLLM can be used for the faster inference and hence could address the time response and latency issues. And along with this discussion, I'll be sharing my GitHub link where I'll be hosting the whole Python code base. There will be two classes. One would be the class that would be training the dataset called train.csv, and we will be setting the test.csv as a file that will test our model against. And we'll have one client related Python file that will be calling that training and test endpoint subsequently using command line parameter. All those would be shared in the GitHub link itself. I hope this had given some good sense of how XGBoost, a simple classical ML model, can help us to do the proactive determination of a transaction that can turn out to be a real-time fraud attempt and can save million and billion of dollars for the companies. There is a link associated with the code walkthrough that we had done. So I hope this had given a good insight of how and what are the prospects we see of using AIML for in the fraud determination pipeline. Thanks for being there.